Okay guys, welcome to this video. We're going to be looking at today an introduction to algebra. Algebra is a wonderful, excellent, amazing area of mathematics, my number 2 favourite after calculus, and you more than likely have heard some horrific things about algebra. It always gets a bad rap in public ideas about mathematics, and people think that because there's letters in there that the numbers just don't make sense and you can't do anything with it. However, this term I'm going to help you understand algebra, so it's going to be a solid foundation for all of your maths. For the rest of high school, the stuff that you learn this term will help you the entire way. If you learn it well and you just become part of yourself, then if you choose to study this sort of stuff later on at university and things, it's going to help you then, because you won't have to relearn it then either. Okay, so this video is essentially just going to give you a couple of reminders of the terminology that we're going to be using. Okay, so don't think that we're going to be introducing too much new stuff today. Right. So a couple of things to know. Pronumerals and variables. So pronumerals and variables are the letters that stand in place of a number. Okay, so your X's, your Y's, your Z's, A, B's and C's, those kind of things. So your X and your Y, those things are called pronumerals or variables. They're the proper term. Maybe you can know them as something different, but you need to know what's being asked of you if it talks about pronumerals or variables. Right. We also write things differently in algebra. So rather than writing A times B, you simply just write AB. Okay. If there's no operation there, you assume it's going to be multiplication. Addition and subtraction stay the same, but division also changes. So we no longer use this sort of division sign. Your division needs to look like this. Okay, so you put one number over the other, similar to a fraction. Okay, it sort of tidies your work up a little bit more, and you'll never have to, well, shouldn't say never, but your order of operation stuff becomes so much easier once you drop the little division sign, that's for sure. Okay, the next thing you need to know about is these things called a term. So a term is a combination of numbers and pronumerals with multiplication and division. Okay, so I might just separate these out a little bit so you can get a bit more of a feel for each individual term. Okay, so 5 is a term all by itself. Okay, because it's kind of being multiplied by a pronumeral that isn't there. We'll talk a little bit more about that later when we've got pronumerals raised to the different powers and things. So 6x, so 6 times x, that's a term all by itself. 7 times y to the power of 3, that's a term all by itself. 45 times f times x, all divided by y, is also a term. Why? Because there is all multiplication and division going on here. All multiplication, all multiplication. We assume there's multiplication against the, as I said, the stuff we can't see. Okay, now a term without a pronumeral is called a constant term. So this 5 here, so 5 is a constant term. Constant term. Why? Because if it was 5x, well, x could be anything. X could be 2. So that could be, if x was 2, 5x would be 10. So therefore that wouldn't be a constant term because it changes depending upon what its pronumeral is. However, 5 has no pronumeral. It's never going to change from 5, so it is called a constant term. Coefficients is a big, important sounding word, but just means the numbers in front of a pronumeral. If there is no number, the coefficient is assumed to be 1. So 5 is the coefficient of 5x, because we look at this term, 5x, and we inspect to see what number is at the front of it. Well, 5 is. Therefore, 5 is the coefficient. If we just had, say, a term is just y, well, if we have a look at the front, what coefficient do we have here? Well, if I put a 1 here, it doesn't change it at all. So we assume that there is a 1 there if there's no coefficient written. Okay? Right. Next, algebraic expressions contain numbers and pronumerals combined with any mathematical operations. Okay? So this here, 46x plus 9xy squared, that's a big expression. X over 2y minus 4 times x plus y to the 5 all squared. I deliberately just wrote crazy stuff down. Don't be scared or worried about it. You'll be able to do all sorts of stuff with these later on. But essentially they're expressions. The difference between them and equations is equations have an equal sign in them and you can kind of do a bit more with them. Expressions is about more to do with learning the idea of some of the tools with algebra. Okay, you'll muck around with expressions with that. Now, to evaluate an expression, however, is simply when you substitute number values into their corresponding pronumerals and calculate the result. So we'll have a look at that in a second. And importantly, this, I cannot understate this enough or overstate it. Please use brackets when substituting. Very, very important. Okay, equivalent expressions, it's more just something you need to be aware of rather than something you need to worry about doing, is that equivalent expressions are equal no matter what value their pronumeral takes. And to test whether two expressions are equivalent, just make all the x's one number or the y's one number or whatever and see if they equal the same thing. If they do, they're equivalent expressions. If they don't, they are not. Okay, just going to quickly show a little bit of evaluating some expressions, okay, because this stuff's reasonably important. So let's just say we needed to evaluate. We're going to have x being equal to 2 and y equal to -3, and I might have 2x plus 3y squared. Okay, so when we substitute, we just simply put these numbers in wherever there is an x, and so we put a 2 wherever there is an x and -3 wherever there is y. And I would like to see you use brackets. So 2 times 2 plus 3 times -3 squared. Okay, so once you've done this, the reason it's a good idea to substitute first with brackets rather than trying to work it all out in one hit is it removes errors rather than you try and do it on your head. And if you learn to do this well, because you do have calculators available now, you can just work out your expression and chuck in your calculator and not have to worry about making errors. Okay, so we're going to do our order of operations. So these two terms, let's work them out. We've got multiplication in them. 2 times 2 is 4 plus, well, we have to do our index here first. So this is -3 times -3 is 9. So it's 3 times 9. 4 plus 27 is 31. Okay, so that's how you evaluate an expression. Okay, it's very important that you do the put the substitutions in brackets, especially when powers are happening. Okay, the reason why that is because this is just an aside over here, is that 2 squared, or -2 squared, sorry, is not the same as -2 squared. Okay, because this, we have to do our powers first, so this becomes the negative of 4 is obviously not equal to -2 times -2, which is positive 4. Okay, so that's why it's very important to use your brackets, especially if you're going to use your calculator, which you should be. It will just do whatever you tell it, rather than thinking, well, did he mean brackets or not? Okay, all right. I hope you sort of understood what was going on in this video. Essentially, again, it's just a whole bunch of words, terms, terminology, sorry, and things that you need to remember the meaning of, so you don't have to worry about those kinds of things in class. Okay. Please bring along any questions to our next lesson, and maybe grab out your textbook and have a go at some of the early algebra chapters. Thank you.